Welcome to Precalculus. I'm going to do a few graphing examples, give you some last minute practice on this topic. So I'm going to start off graphing y equals negative 5 cosine 2 theta. So a couple of notes before we graph. Our amplitude is going to be 5. I put a little star next to it because it reminds me that I'm going to start down for cosine. And b is 2. Therefore, my period is going to be 2 pi over b. It's always 2 pi over b for sine, cosine, secant, cosecant. So my period is going to be 2 pi over 2. And that's going to give me pi. Critical distance is always period over 4, so it's pi over 4. Okay, now you will have graph paper when you do this on the test. I don't have graph paper here, so I will make do, but I'm going to do it as if I had graph paper, kind of. Rather than going out to 2 periods out here and calling it 2 pi, I'm just going to count it off. So my first tick mark on my graph paper would be pi over 4. My second one would be pi over 2, which is 2 pi over 4. So basically, I'm going to skip one here and do 4 tick marks I have total now. That would be 4 pi over 4, which is pi. And 4 more would be 2 pi. And halfway between there would be 1.5 pi or 3 pi over 2. So I got my x scale done. Y scale, my amplitude is 5, so I'm just going to go up 5 and 5. Now, again, if you're doing this on graph paper, and the stuff that I gave you, you have 3 boxes above and below the x-axis. I'd just probably go 2 or 3 boxes, probably 2. And now we have our scale done. And you can see, since the period is pi, we need to go 2 pi radians to get 2 full periods, and we got that covered here. So I will start down because of the star, and then now I'm just going to walk my way. It's like any sine or cosine would do, from minimum to equilibrium to maximum to equilibrium and back to minimum. I run out of time, or out of space, it looks like, and I'm back where I started, so I've done 2 full periods. Do my best to make this look decent. Oh, it's okay. Alright, 2 full periods. So that would be, I have a basic cosine one. Let's do another. This is a, let's do a sine one. This is y equals, okay, we're going to do y equals 2 sine pi over 2x plus 3 pi over 2 minus 1. I actually have not even tried this one, but I think it should work out pretty well. Lots of stuff happening here. You'll probably see one like this with lots of stuff happening. So I don't know if we'll get all this on the same graph as my notes. I'll try. So my A is 2. No negative, so I don't need, it'll start at equilibrium and we'll move up first. My B is pi over 2. Therefore, period is 2 pi over 2. And you can check me on this. That's 4. So my critical distance is a really nice 1. That's about as good as it gets. Okay, what else? Since my amplitude is 2, my range is going to be from negative 2 to 2. However, since it's going to shift down, that's wrong, right? It's going to shift down 1. So it changes to negative 3 to 1. You don't have to write that, but I guess I was meant to put a 1 there. You don't have to write the range, but I think if you do, you don't have to think about that much. You just check your range out, and that's where your min and max is. Lastly, the start-stop thing. So you set what's in the parentheses. Sorry about this. Let me erase that. You set what's in the parentheses equal to 0. And the idea, again, is you're saying, when does this thing in the parentheses equal 0? Because if it equals 0, if that equals 0, then I'm signing 0. And when I sign 0, that's the beginning of sign. I mean, sign of 0 is 0. So you're finding out where is the, for all intents and purposes, where is the beginning? Where does it start doing its normal thing? It starts doing its normal thing when it starts signing 0. When does it start signing 0? When this thing is 0. So hopefully that makes sense. You just have to memorize it, but that's where it comes from. Okay, I try to pick something that's going to work decent for us here, because when I move this over and divide by pi over 2, if you have 3 pi over 2, you divide by pi over 2, oh, and by the way, there's a negative, you get 3. That is my start. Yes, it's not really a start, it's infinite both directions, domains all reals, but the best thing I can think of to call it. Okay, everything's set here. I don't want to put my y-axis there, because I'm going to start at -3. I'm going to put it about here. That's a terrible y-axis. Okay, finally ready. That's not a great y-axis either, but it will have to do. Well, sorry about this. Can't help being that sloppy. Okay, so eventually my period's 4. I need to go left 3. 1, 2, 3. My period is 4, so that means that I'm going to need to go 1 more to the right, and that would be a full period, right, from -3 to 1. So I only need to go 4 more. 1, 2, 3, 4. You don't have to label all these, but it's almost, the numbers are so easy to label, I'm going to do it. Okay, now I probably could have drawn my x-axis taller, because I'm only going from -3 to 1. That's okay. So I'm going to go down 1, 2, 3, and go up 1. That's where all the action's going to be. Okay, so I think everything's ready. I am starting 3 to the left, as we see here. Starting 3 to the left. So I will move 3 left and put a dot at the equilibrium place. Now, where's the equilibrium place going to be? Well, we said it shifted down 1. That's one way to think of it. So it's going to be at -1. Oh, all these things are going to be all right on here. So it's going to be at -1 is the y-coordinate. Or you could think of halfway between -3 and 1 is -1. But the best way is to think of it's shifted down 1, so my equilibrium is at -1. And then it just follows normal from there. The critical distance is 1, so I'll just go up 1. Sine always goes up first, back to equilibrium, then to a minimum, which is going to be -3, back to equilibrium. We have to keep remembering that our equilibrium is not at 0, it's at -1. And we should be back where we started. Since I made my labels, unfortunately, on the bottom, they're getting marked through. That's okay. I think that's going to be it. Let's see how it looks. Ooh, it wasn't great. Decent. Would look better on graph paper, but that's it. Everything's labeled well. looks good to me. I don't know. Let me know if I made a mistake, but that's a pretty typical sine and cosine. I'm going to make another video with, I think, a tangent and a secant or a cosecant, so stay tuned for that one.
Made with Doodlecast Pro.